Hi everybody, welcome to another video in trigonometry. Section 1.3, trigonometric functions. So this section we define the trigonometric function. So let's just go right into it. So let the point P has the x and y coordinates be any point other than the point 0, 0. The terminal ray, and that point is on the terminal ray. So because the initial ray is the positive x-axis, so the angle in the standard position, because we have that in the standard position, the initial ray is the positive x-axis, the terminal ray, we can pick any point on the terminal ray. So we can choose any point on the terminal ray. Let's choose that point. So this point, x and y. So with that we have here the y values. And here's the x values. And let the hypotenuse of that right triangle be r. So we have x, y, and r. So pick a point on the terminal ray. We have x and y have the hypotenuse, that's r. Right. Once we have that, we define the 6 trigonometric function as follows. By the way, this is the abbreviate. Sine, if we want to spell it out, this would be sine of theta, if we want to spell it out. Is y over r. This is cosine and this is tangent. Cosecant secant, and then cotangent. Right. Abbreviate using 3 letters. So sine is y over r, cosine is x over r, tangent is y over x. Like I said, this is just definition, so we just have to go with it. Apparently there is no trick to memorize this. We just do a bunch of problems, get used to it. That's pretty much it. There's a different way. There are 2 more different ways to define trigonometric function, and the other way is a little bit easier to memorize. But right, sine y over r, cosine x over r, and tangent y over x. Usually you should know those 3. And then the other 3 will be reciprocal. So sine and cosecant, y over r, r over y. Secant and cosine, x over r, r over x. And then y over x, x over y for tangent and cotangent. So those, the reason we write like this, so they have the reciprocal relation, meaning we just flip the fraction and we have from one to the other. Right. And one important thing about this relation is this is the right triangle, so we have x squared plus y squared equal to r squared. And last thing, when we write the ratio, we just make sure the denominator not equal to 0. So x and y cannot be equal to 0. But then we say y, r, we don't have to write that. Well, if the point is different than the origin, there is the distance between that point and the origin, therefore r is not equal to 0. Because the point is older than the origin, meaning that r is not equal to 0. That by definition. So we define with that condition. Right. So I said those are the definition. So I'm going to write this in the 3x4 note card. So I might refer to this many times later. So sine y over r, cosine x over r, tangent y over x, and the reciprocal of that. Cosecant is reciprocal of sine, r over y. Secant, reciprocal of cosine, r over x. And then cotangent, x over y. And of course, if we divide by x or divide by y, they have to be not equal to 0. Right? So we will refer back to this many times. Right, so have the first example here. The position has the point 3 and 4. So pretty much in this example, what we have, x equal to 3 and y equal to 4. And then we can find r with x, y, and r. Once we have those three, we can define those. We have r squared equal to x squared plus y squared. So 3 squared plus 4 squared. So r squared 25. So r equal to square. Once again, r is the positive. Right. We have x and we have y. Right. Now we just write the definition. Sine y over r cosine x over r tangent y over x. R over y. Secant r over x cotangent x over y. And we have x, y, and r. Just put the numbers in. That's pretty much it. Sine is r. Cosine x over r. Tangent y over x. And the cosecant is reciprocal of sine, so we just flip it. 5 over 4. 5 over 3. And x over y. Yeah. So just like that. Very straightforward. Just a definition. Follow that exactly. Once we know x, y, and r. Right. Next example. The terminal side of the angle theta containing the pole -1 and 3. So we equal to -1. Y equal to 3. Of course, from this we can find r, which is r squared x squared plus y squared. Or we can say r is square root of x squared plus y squared. Square root of -1 square plus 3 square. 1 and 3, that's 10, square root of 10. So r is square root of 10. X is -1 and y is equal to 3. Right, put everything in the definition. I just write the definition out. Sine y over r cosine x over r tangent. Right, let's write some, give some space. Cosecant reciprocal sine. Secant reciprocal of cosine. And cotangent reciprocal of tangent. And we have x, y, and r. Put it back in the definition. And that's right. Y over r, 3 over square root of 10. Just one thing though. Usually in algebra, we don't want to put the square root at the bottom. So in that case, we still want, if we want to multiply square root of 10, top and bottom. So in which case, we have 3 square root of 10 on the top. The bottom square root of 10 times square root of 10, that is 10. Right. So sometimes we have to multiply by that to irrationalize the denominator, meaning we turn that into the ratio. At the bottom is no square root in it. Right. Cosine is x over r, negative 1 over square root of 10. And once again, if we want to, we can multiply square root of 10 top and square root of 10 at the bottom. So at the bottom, square root of 10 times square root of 10. This is just 10. Tangent is y over x. Y over x, 3 over negative 1. So give us negative 3. Right. And then cosecant is the reciprocal of sine. So we just have 3 over square root of 10. So that's square root of 10 over 3. Or we can write 10 over 3 square root of 10. But just take that, flip, that's it. R over y. Right, secant r over x, r square root of 10 over x. That is negative square root of 10. And cotangent x over y. So yeah, that's it. Straightforward, just definition. Right. Now we'll do a lot of example of this. But now for special trigonometric function values for special angles. This special angle we have the values, and later on, not try to memorize. The point here is we do enough problems so we know the values. Right. So let's look at this. By the way, let's write the definition. Sine is cosine x over r, tangent y over x, cotangent x over y, secant reciprocal of cosine r over x and r over y. So those are the ratios. Table. These two are reciprocal of each other. These two are reciprocal of each other. And the side are reciprocal of each other. Right. Now, the values. 0 degrees. Of course, that is the positive x-axis. So we will pick a point here. And so this is 0 degree. And the point here, like I said, by definition, we can choose any point on the terminal ray. Now the terminal ray is, so we will pick the point here, choose the values, and here strictly choosing. We can choose x to be 5, y equal to 0 because on the x, so y equal to 0. We can choose 5, 0, and then subsequently r is equal to. Have 1 for x is equal, and then because of that, r equals square root of x squared plus y squared. Distance to the origin is 1. So for 0 degree, we have x, y, and r. Value y 0 over 1 y over r, so 0 over 1 is 0. Next, x over r, x 1 over 1, tangent y over x, y. Now, can we? So in that case, this is undefined. And then r over x and r over y. Divided by 0 once again is undefined. Simple enough, right? So that is 0 degree. Next, 90 degree. 90 degree is here. That is the terminal ray. So we can just pick up. So the terminal ray is calculated from there. So 0 because that is on the y-axis. And it is positive y-axis. So why don't we let y equal to 1? And because of that, the distance to 0 is 1. Or we can use Pythagorean theorem to find the r. So r is equal to 1. Y over r, y over r, x over r, y over x, divided by 0 is undefined. X over y, x over y, anything divided by 0, 0 divided by anything else is 0. R over x, r over x is undefined. And finally, cosecant r over y. Simple enough. Next, 180 degrees will be negative x-axis. So in that case, let's choose the values. Let's pick a point here. This is on the x-axis, so y equal to 0. And it is negative, so we choose x to be negative 1. Again, we can choose any point on this terminal side. Would be good. We can choose negative 5, 0, negative 10, 0. It doesn't matter. In that case, r is distant from that point to the origin. Or we use Pythagorean theorem. The distance is going to be 1. Because from negative 1 to 0, the distance is 1. Right. And then fill in this table. Y over r is 0. X over r, x over r, y over x y over x is 0. Right. Over y. So that is undefined. R over x R over y is undefined. So just straight from the definition. Now 270 degrees is negative y-axis. That's the terminal ray. Pick a point here. X is going to be 0 and y we choose something negative. Y over r x over r y over x and divide by 0 is undefined. X over y even with the color code I might look at y over r x over r y over x. It's easy, but just have to be careful. X over y is reciprocal cosine, so r over x, r over x. And r over y. Right, like I said, just straight from definition. And also you see this is have kind of reflection. I mean, I'm not reflection, I should say reciprocal. Reciprocal of 0 is reciprocal of 1 is 1, 0 and undefined. 1 and 1, 0 undefined, undefined 0. 0 undefined, negative 1, 0 undefined. Those are reciprocal of each other. Undefined 0, 0 undefined, negative 1. Those are reciprocal of each other. Right. But other than that, just straight from definition. Right, next we'll do trigonometric function values for 30, 40 and 60. On this one there's a trick for that, so it's not that bad. But first I want to put 0 and 90 degrees here, so let's just copy the 0 and 90 degrees. The 0, the sine, cosine, tangent, cotangent, secant, cosecant. Let's put the trig function sine y over r, x over r, y over x, x over y. Secant is reciprocal of cosine. So x over r, so this is r over x. Cosecant reciprocal of sine. This is y over r, so we have r over y. We just flip them. We already know the values for 0 degree. 0, 1, 0, undefined. That's from the table we have earlier. For 90 degrees, sorry, it's 1, 0, undefined, 0, undefined, and 1. Right, now we determine 30, 45, 60, and 90. There's a trick for that has to do with the hand. Right, so if we don't want to use that, just strictly from definition, let's say if we have 30 degrees, so remember the 30, 60, and 90 degree triangle, the relation is going to be 1/2. So we have 3 over 2 and 1. So we can use x, y, and r. This is y, this is x, and this is r. And we can use those values and the trig values for 30 degrees. It's not that bad. Same thing for 45 degrees. Square root of 2 over 2. Square of 2 over 2 and 1. And then same thing for 60 degrees. Square of 3 over 2. X is equal to 1/2 and r is equal to 1. So we have this in the second section, special right triangle. Opposite to 30, the ratio, the opposite to the angle is 30, 45, and 30, 60, and 90 degrees. The ratio of the sides is 1/2, square of 3 over 2, and 1. So that's pretty much what we use. This definition we can write on the trig values here. We're not going to do that. There's a little trick for that, and this is this trick using the hand. So we have that called earlier. I'm going to put on the back. Just try to draw a hand. Right, so just 5 fingers. Now, the way we do this is we go counterclockwise. From 0 degree, 30, 45, I should draw this bigger, 60, and 90. So those are the special values, 0 and 90, and between them 30, 45, and 60. So those are the values, right? Now go from left counterclockwise. Now we define this thing. The sine of whatever the angle is will be equal to the number of the finger on the right divided by 2. So we have square root of number of right finger. I found this on the internet. For example, let's pick one, 30 degree. If it is 30 degree, if the hand here, we're going to 30 degrees here. So we put that. and on that there's one finger on the right. So in that case we have one finger on the right, and we have square root of that over 2. So let's just write. So square root of 1 over 2, or 1/2. So, and then 45 degrees, that is the third finger. So we put third fingers there. So 45 degrees here. There are 2 fingers on the right. So we have square root of those 2 over 2. So we square 2 over 2. 60 degree is these fingers. And there are 1, 2, 3 fingers on the right. Just that. So we have 3 over 2. And then 90 degrees, there are 4 fingers on the right. So this is square root of 4 over 2. Square 4 is 2, 2 over 2 is 1. And then 0 degree, that is the thumb. There's 0 finger on the right. Square 0 over 2 is 0. So sine is the number of the right fingers divided by square root of the numbers of the right fingers divided by 2. Cosine is the left square root of the number of left fingers divided by 2. Right. So 0 degree, there are 4 fingers on the left. Square 4 over 2, which is 1. Next, 30 degree is these fingers. And we just cover that fingers. And on the left, there are 3. 45 degree, the middle finger, 2 on the left of it. 60 degree, the ring finger, there's 1 on the left. Square root of that number divided by 2, so 1/2. And then 90 degree is 0 divided by 2, which is 0. Right. So we use the hand trick. Give us sine, cosine easily. They'll say, how about tangent? Well, tangent is a little more difficult. Number of the finger on the right divided by the number of square root of the fingers on the left. So this is the trick of the hand trick will give us the nice values for 0, 30, 45, 60, and 90 degrees. Right. Now, so 0, 30, 45, 60, and 90. Right. So, right, the number of fingers on the right, so 30 degrees. Have little straw here, 30 degree is that. Number of fingers on the right, there's 1. Number of fingers on the left, 3. So square 1 is 1, so we have 1 over square root of 3. Next, 45 degrees. 2 fingers on the right, 2 fingers on the left. Square root of 2 over square root of 2 is 1. And then 60 degrees. 3 on the right, 1 on the left. Square of 1 is 1. So that's what we have. So this trick will come in handy. Of course, when we used to do this, when we get used to it, we can kind of memorize it just like with the multiplication table. If we use enough, then we have it. Right. And you'll say, how about the other 3? Well, the other 3 are reciprocal of this. So now, this will be a reflection. Reciprocal. 1 over square root of 3. So this will be just square root of 3 over 1. This is kind of reciprocal. Reciprocal of 1 is 1 over 1, still 1. Square of 3 over 1, so it will be 1 over square root of 3. So reciprocal, those are reciprocal of each other. Next, cosine secant are reciprocal of each other. So I'm just going to flip 2 over square of 3 over 2. So this will be 2 over square root of 3. Square of 2 over 2. 2 over square root of 2. 1/2 or 2 over 1, which is 2. Yeah, just flip, and we have the other 3 trig function. And the sine cosecant are reciprocal of each other. 1 over 2, 2 over 1. Square of 2 over 2, 2 over square root of 2. Square of 3 over 2, 2 over square root of 3. Yeah, so with that we have our table. So again, the hand trick should be handy. Left hand or right hand, it doesn't matter. What matters is the angles go from counterclockwise: 0, 30, 45, 60, and 90 counterclockwise. And then sine is the right number of square root of the right fingers divided by 2. Cosine square root of the left fingers divided by 2. Tangent is that. So this trick I found on the internet. There may be some more, but I think this is handy enough. Right. Next, the sign of trigonometric function. So up to this point, every trigonometric function, we go back to definition. Definition. This. By the way, if you have a 3x5 like this, we refer to this more often than not. So keep that on the same place. Right. Suppose theta is not a quadrantal angle, meaning it is not 0, not 90, 180, 270, and any coterminals to that. And so we have the x, y in one of the quadrant. So in quadrant 1, quadrant 2. So I have 4 colors, so I just use different colors here. And 4. So let's say if we have a point in here, then x is positive, right? Y is positive, and R is positive. Negative. This is much better. Sorry. Let's use positive instead. So on that, the first quadrant, all of the x, y, and r are positive. Now, if all of them are positive, the definition, all of them will be positive, right? Write the function that are positive in each of the following quadrants. all of them are positive. Because x, y, and r are positive. They're on quadrant 2. Which one is positive? If the point is here, x is negative, still positive, and r is always positive. So with that, which one of these are positive? Now, think about ratio. X, y, and r, there are 3 of them. We pick 2 of them to form a ratio. So if we have to choose 2 of them, if we choose a negative and a positive, their ratio will be negative. If we choose 2 positive signs, the ratio will be positive. So the only function that is positive is the function that have y and r, because positive divided by positive is positive. So out of those, which one has y and r? Well, the sine and the cosecant, right? So sine is positive. Reciprocal of that, cosecant is positive. Next, third quadrant. So if the point is there, x is negative, y also negative, and r always positive. Right, now pick 2 out of those. Which combination will give us a positive? Now if we have a negative and a positive, the ratio will be negative. If they have the same size, like both of them being negative, negative divided by negative is positive. So we choose the ratio that have y and x in it, that will be positive. So y and x, those are tangent. So tangent is positive. Cotangent is also positive. Now on to quadrant 4. Quadrant 4, x is positive, y is negative, r always positive. So if we want to get a positive function, by the way, when we write this, everything else are negative. I will do that in a minute. But in quadrant 4, if we need something to be positive, we have to choose x and r. Positive divided by positive is positive. So x and r, that cosine and secant. So cosine is positive. Reciprocal cosine is secant is positive. Right. Usually we just use sine, cosine, tangent. When I go to school all the old day, we just have those 3 functions. And the cosecant, secant, cotangent are reciprocal, so we not even study about those. That's when back in the day when I study this thing, just sine, cosine, and tangent. Actually cotangent too, but I didn't have secant and cosecant back in the day. Right? Like I said, when all things fail, go back to definition. Right. When we have all positive, of course all of them are positive. Sine and cosecant are positive. Everything else is negative. So others are negative. Tangent, cotangent are positive. Others are negative. Cosecant cosine and secant are positive, others are negative. So we worry about the positive case here. Right. So 1 1, 1 2, 1 3. Right. The way I memorized this when I studied back in the day. Quadrant 1, 2, 3, 4, ASTC, like own store, tech, cash. So the first quadrant own are positive, second sine and reciprocal cosecant, third quadrant tangent, reciprocal cotangent, fourth quadrant cosine. At least you have to know the definition, because everything just go back in terms of x, y, and r. Let's look at some example here. That is positive, cosine negative. Which quadrant we're talking about here? Right, just of course we can use this too. But tangent, what is tangent? Y over x. And this is positive. Sine x over r. This is negative. Quadrant we're talking about here. So, first of all, y over x is positive. What does that mean? Meaning that y and x have to have the same sign. So both of them are negative. Talking 1 and 3 here. And then cosine is negative, meaning that x has to be negative. Because actually when we look at this, the sine, cosine, secant, cosecant would be easier. A tangent, cotangent, it could be positive. Both of them could be positive. Both of them can be negative. Right. So actually, I will base on this. Cosine is equal to x over r. We know for sure this has to be equal to negative, right? It had to be negative. Always positive because we define r to be positive. Then what is x? Want the ratio to be negative, and one of them so have to be negative, right? So x is negative. I should write less than 0 or greater than 0 for negative and positive, but I think using the sign like this is easy to do the math, easy to process. X has to be negative because the whole thing is negative. That's what given. Right. Next, tangent is this. It's positive, meaning that x and y have to have same sign. Same signs. Because positive divided by positive is positive. Negative divided by negative is negative. So we have x is negative and they have the same sign. So y is negative as well. And what quadrant where both of them are negative? That is in quadrant 3. So later on we can just do this in our head, but this is the thinking. Usually we prefer sine, cosine, secant. We know r is positive. Tangent tangent can only tell us if they have the same sign or opposite signs. Right, that's simple enough. Like I said, when all things fails, go back to the definition x, y, and r, and we can reason everything reasoning based on x, y, and r. Next, given that tangent is 3/2 and cosine is negative, find the exact values of sine and sec. So, like I said, everything will break down to x, y, and r. Once we know those x, y, and r, we can find all the trig function. So first thing we do here is find x, y, and r. Right, we have tangent is equal to 3/2. That's good. Cosine is negative. So usually tangent kind of, we don't know if they have the same sign or not, but so we have to use, if there's sine, cosine, we base on that first. Right, so we look at the cosine. Cosine is x/r. We don't know the values, but we know that it is negative. Because that's what's given. Now, r is always positive. So what will be the sign of x? Right, something divided by positive is negative, so x has to be negative, right? Right, so check the sign. Next, tangent is positive. It's positive. We worry about the later. Now focus on the sign only. Now we know that x is negative. If x is negative, what is the sign of y? Well, if they have to be, must have the same sign, so y is negative. As well. And then we can say after that tangent is equal to 3/2. And that is also equal to y/x. So this naturally we can say y is equal to 3, x equal to 2, right? But no, because we know the size here, so we have to choose y to be -3 and x to be -2. I know I might write a little more steps than I need to, but these are to consider. Right. So first, when we look at the problem, we can determine the size of x, y, and r. Once we know the sign, we can go to the values. Now the values is that, right? So -3/-2 is, typically if they are positive, we just choose the values. It's negative. Right. We have x, y, and then r will be square root of x, y. Y squared plus x squared, doesn't matter. 9 and 4 square root of 13. Right, so that's the first step. We find out x, y, and r. Right, and after that, we just find the question answers for sine which is y over r, y over r. In my class, I'm perfectly fine with giving the square root at the bottom. Having the square root at the denominator is perfectly fine. And then secant. By the way, we don't need to do this. Secant is the reciprocal of cosine. Actually, we don't have. Still need to do that. X over r, x over. Right. It's easy once we have x, y, and r. Right. So it's not that bad, right? So first look at the size, determine the size of x, y, and r, and then we determine the values. So simple enough, right? Yeah. So cosine is negative, x negative, tangent is positive. They have the same sign, so y is negative. Right. So those are the sort of things that we need to reason. Next, given that cosine is 4/5, tangent is negative, find the exact values for cosecant. Once again, the first step we do is find x, y, and r. And usually we go with the sine, cosine, secant, and cosecant, something that has r to pivot when we know exactly r has to be positive. So first, if we worry about the sine only, cosine is equal to x that is positive. Cosine is positive, and r is always positive. So x must be positive as well. Yeah, when you get used to this, you can do all of this. We can do all of this in our head. So we have to. Now, everything that we need to accounting for is here. Tangent is y over x is negative. We know now that x is positive. So what is the sign of y? If x is positive, then y have to be negative if the ratio is negative. So y is negative. We know r is always positive, so we don't have to worry about that. Right, so we know the size. Now the values. Cosine is 4/5. Which is also equal to cosine is x over r, right? Actually, we don't even need to reason because r is 5 is positive, x must be 4. So from here we can say x is equal to 4 and y is equal to 5. There's no other way around. R has to be positive 5 and x have to left with 4. Unlike this, where we can choose both of them to be positive or both of them to be negative. Both of those cases still guaranteed to be positive, and we choose negative, of course, right? So that's why I said I prefer to work with sine, cosine, secant, and cosecant because there are in it. I know for sure. And r is 5. Sorry, not y. So we have x squared plus y squared equal to r squared. So we can find y. square root could be plus or minus square root square 5 square minus x square 25 16 plus or minus plus minus square root of 9 plus or minus 3, right? Remember, r is always positive, so we don't worry about plus or minus. But when we solve for x, we solve for r, could be negative, could be positive. So always put plus or minus when we solve for x or we solve for y. And in this, y is negative. So y is negative 3. There's x and there's r. And now we find cosecant is the reciprocal of sine, or you can write like 1 over sine. Sine is y over r, cosecant is r over y. R over y. Right, so cosecant is r is 5 and y is negative 3, so that's what we have. So I know you might probably think that I write too much here, which is fine, like I said. Of course, you can do all of that on our head. We can do all of that in our head, but those are all things that we need to think about when we do this kind of problem. So first step, I'll write everything down. Right. In this section, just boil down to the definition of the trig function, and then later on we have the values, and we use the right hand trig. Alright, so with that I stop the video here. We're done with section 1.3. See you in another video in trigonometry. Thank you for watching.